Hello, hello. I'm Chris with the Legacy team, and this is a three-part series on how to take a photograph of a spindle that is either broken or old that we need to replace, and we're going to be designing it, programming it, and finishing it on the machine. We already did part one in the designing process, and this is part two where we're going to focus on the programming aspect using two software packages of Maverick software and CCAM Pro software. So let's go see how it's done. Well, welcome to part two on creating a spindle from a photograph image. In part one, we had taken the time to take this image of a broken spindle or an old one that we need to replicate, and we matched the design, and we can see that if we highlight here, you can see we've matched the design to that image, and everything is symmetrically balanced, so you have the same profile on both sides, and this is all symmetrical and dead center for our grooves and our coves, and this is perfect, ready to be tool pathed. Now, what we need to understand is how this is going to be tool pathed, and that's what we're going to focus on in part two. We're going to be using CCAM Pro as our main programming software to generate the toolpath files for Legacy's CNC systems, specifically using the Turning Center workstation. Now, the one thing that we used to have to do in Conversational CAM Essentials before we went to Pro is this profile would have to be broken into individual lines, and we would create a toolpath for each line. And that was really time consuming to create that toolpath in order to do something this complex, right? However, this new method with Conversational CAM Pro allows us to take a GCode file that we generate here in Maverick, and this will just simply be a 3-axis flat stock toolpath. So the cutter, for example, will cut on this side of the line, just following that shape, using X, Y, and Z, no rotary for the Maverick software. And we will save out that G-code and then import it into Conversational CAM Pro, this software. And this software will actually convert that 3-axis G-code directly into a 4-axis rotary application, but still following this layout for the cutter. So this definitely speeds up the entire process when you're duplicating spindle work like this. So we're going to use two software packages in conjunction to make this as fast and as simple as possible in order to get to the machine for part three, where we're going to set up and actually cut the spindle itself. Now, the first thing we need to do is we have this vector here that's all joined together as one continuous line, because that's going to be one tool path for that one line. And then we have a separate one over here in this line. There's two things that we need to make sure happens with the vector before we create a toolpath itself. The first thing we need to do is we need to make sure that all of these lines are being converted to what are called curves or Beziers instead of keeping them as arcs. For example, when we drew this curve right here, that was drawn as an arc so that we can make it symmetrical, but we need to convert that first. To do that, we highlight the line, and then we come over here to this curve fit or fit curves to a selected vector tool. And here we can convert everything to arcs, Beziers, or straight lines, and it will hold the tolerance that we put in here. I just put in 1/10 of a thousandth of an inch. And so if I go Beziers and preview, and we can replace the select vectors, it's still going to hold the design, but instead of this being arcs now, these are all now Beziers. And that's important for the coding language that we're going to be using in Conversational CAM Pro. So now if we look at node editing, we can see everything is all broken into these kind of blue lines mostly. Now there are straight lines, like these. That's a straight line. There's a half of a Bezier here. But these are already ready to use now. We need to do the same thing with this guy over here. So we'll take this line, convert it to our Bezier curves. Again, a tight tolerance, and preview, and okay, beautiful. And this guy's ready to rock and roll as well. Now, the last thing we need to do to prep these vectors for the toolpath is we need to make sure the starting point, when we select this node in version 12, it actually shows this dark node on the right-hand side. That indicates that's the starting point for the vector. If we need to change that, because I do want to actually cut this from left to right, I find it just does a smoother cut when we do that. So we need to change the starting point here to the left side of the vector. Simply to do that, we go to Node Editing, okay, here, or hotkey letter N, and now it shows all the individual nodes, and we can right-click on this end, and we can say Make Start Point, and you can see it changes it to this brighter node. And if we deselect and turn off our node editing, you can see that the dark node here that used to be on the right side is now on the left side, indicating our new start point. So let's go verify that this one is set up correctly. And this one is. I already have it on the left-hand side because we did a mirror copy with the design, and so that makes sense that this one's on the right, on the correct side because of that copy in the previous video. So we don't have to modify that at all. Now we're ready to create some toolpaths. So with that in mind, let's just turn our bitmaps off so nothing's confusing. We can kind of see what's going on. I'm going to select this profile cut, and we're going to be having a cutter follow this line to generate a toolpath. Now the toolpath to do that is called the profile toolpath. So let's select that. And we're going to be using, because it's getting into some tighter details, I believe I drew these curves here with an 1/8 inch circle to match what the 1/8 inch cutter could do as details in the material. So we're going to be using, in the end, an 1/8 inch tapered ball cutter to actually turn this detail work. Same with this other end over here. And then the rest of the spindle is simply going to be turned around using a big flat surfacing cutter to turn it to a cylinder diameter all the way through and through. So we'll use 2 cutters throughout this entire process. For the toolpaths that we're generating from Maverick as the 3-axis toolpaths, we're only going to be generating them for the 1/8 inch ball cutter that we're planning to use. Okay. Now, we have to pay attention to a couple things in the toolpath to make sure it's set up correctly. First thing is, it doesn't matter what my cut depth is. So I'm going to use an easy round number that's easy to remember, 1. Okay, so if I put a cut depth of 1 in there, it doesn't matter if it's cutting through my material or not. I'm just making sure that it's a simple number that we can use. The second thing that we're going to be doing is selecting a tool that is going to match the same diameter as the tip of the tapered ball cutter that we're going to be applying in CCAM Pro. So if we're going to be using an 1/8 inch tip, I need to use an 1/8 inch diameter cutter. And it doesn't matter if it's an 1/8 inch 2-flute straight cutter or end mill or V cutter or ball cutter. It doesn't matter what the diameter of the tool is, as long as it matches the diameter of the tip of the taper ball cutter for CCAM Pro. So I'm going to select, in this example, an 1/8 inch end mill. Okay, it doesn't matter any of the toolpath parameters and cut depths and feeds and speeds are going to be. Those are all going to be overridden back in CCAM Pro. So we're going to select the 1/8 inch cutter, and this is we're selecting the same diameter so that it calculates the right location where to cut along that line, so that we calculate the right positions in CCAM Pro. Okay, and it's going to do all that automatically. We just need to make sure they match. So with an 1/8 inch cutter, we're cutting, let's say, at 1. The only thing I need to verify is that it makes whatever I put as my cut depth, it does it in 1 pass. So I have 8 passes here. We're going to edit our passes and just bring this down to 1. Okay, there we go. So one pass with an 1/8 inch cutter. Everything looks perfect. And now we have to determine on which side of the line we need to be on. So we're not going to cut on the line, because that will the cutter will then span across both sides, and that will remove additional material in our spindle that we don't need. We need to be cutting on the upper edge of this line, so that we're putting the tip of the cutter is pretty much following these edges, so we get the exact result as if we're cutting from the top. Okay. So we're going to be cutting on either the outside or inside, or in this case, they have these / right and lefts. And that's to help you determine whether you're using an open vector or a closed vector. So a closed vector is like a circle. So if I drew a circle, that's a closed vector where it loops back onto itself. And that could be a square, a rectangle, anything that loops back onto itself regardless of the shape is a closed vector. This line, though, if we select it, we know that it's an open vector because it doesn't loop back onto itself. So the outside and inside text here is referring to a closed vector, and that makes sense. If we had a circle, we could cut on the inside of the circle, or if it was outside, we would be cutting on the outside of the circle. Right and left are determined from an open vector standpoint. So if I look at this vector and I have my start point right here, if we were standing, literally if we were standing right here looking down this line, okay, this would be a kind of a sky view, and we're looking at the top of our head here, and I'm peering down this line, which side of the line do I want to cut on from that perspective? Well, technically, if I'm standing here, this would technically be the left side, and this would be the right side. Okay, so that means all of this would be the left side of the tool, or left side of the line, and this would be the right side of the line. So I'm going to choose left, okay? Again, based on the perspective from the start point of the vector line itself. If we were actually from the other end, if this was our start point, we want to cut on the right side of the line, because looking down that line, this is the right side versus the left side. Again, based on perspective where the start point is. So this is now set up correctly. We can, my edit passes shifted to 8 again. Make sure I get that back down to 1. It probably shifted after I changed my vector selection, so that's fine. So now that we got that locked in, we don't need to add ramps, because that's what this line does automatically, is ramping for us. And we're going to give this now a title, such as, I'm going to call it Contour 1, and I'm going to also call it for import. That's because we're going to import this G-code directly into our Conversational CAM Pro software. Okay, and now we can push calculate. And it may give you warnings like it's going to cut through, but again, don't pay attention to that, because all these numbers and parameters are going to be overridden in Conversational CAM Pro. So now that we've generated our G-code, so now that we've generated our toolpath, we can actually simulate it just to see what it does. So it follows from left to right. We can even turn on our vectors here, and you can see it follows that line beautifully right along the top, giving us that result. You can delete these if you wanted to, and you can see this is a side cut, is really what it is, because it's the 3-axis side cut. But this will be converted in Conversational CAM to cut from the top using these parameters, which is really cool. So now that we have a toolpath for this side, let's go duplicate that for the other side. And it's as easy as simply right-clicking on this toolpath and duplicating, because we want the same numbers, same parameters. We just select this vector instead, and then modify our name. So this is Contour 2 for import. Okay, we can go to this side and preview that one. And yeah, cuts from left to right exactly how we want it to be. You can see that the cutter is going to lift up, giving us that chamfer along the corners, as it's constantly going to be turning from round to a square section. So these look great. And again, these are just 3-axis functions. So we can check both, well, actually we can check both these toolpaths, but I'm going to break these up into individual toolpaths themselves when we generate our G-code. So I'm going to uncheck number 2, just have number 1 checked, and let's go save this out as a G-code or a toolpath file. So if we go save toolpaths, and originally when we're doing flat stock components, we use the 3-axis delta. When we're doing wrapped carvings, we use 4-axis delta. This is a new technique altogether. This is where we're taking a 3-axis G-code and we're converting it into a 4-axis rotary in Conversational CAM Pro. And so we created a post processor specifically for this called Legacy G200 Turning Delta. And that's because G200 is the coding language that CCAM Pro is going to use to have the stock continually rotate as the cutter is following this profile shape along the top surface. And so it's going to convert from a side cut to a top cut for us in CCAM Pro while constantly rotating the blank. That's everything that's going to take place. So let's save this toolpath, and I'm going to put this where I'm saving my project files right now anyway. So I'll put this down here under Technique, Contour Turning from Photo. And so Contour 1 for import is my toolpath file. That's perfect. And then we'll uncheck and check the number 2 contour, which is this other side over here, and save that one out. And this will be contour number 2 and save. So now that we've saved our G-code, we're now ready to bring that into Conversational CAM to finish off the toolpath programming for this spindle. So in CCAM Pro, let's go set up the first processes and toolpaths just to turn it all around. So we have to set up a blank size on a project here in CCAM Pro. So we go to projects in the top left corner. These are all the projects that I've done in the past, but we can create a new one for this particular spindle. I'm going to call this Baluster from Photo. Just for now, you can title anything you want. And we are obviously using the turning center for this application, and we can push save. And if we look here, we have a Baluster from Photo project now added to our project list. I can select that project, and this has now the turning center because I checked that in the project setup. If we click that, we can now manage our parts under that turning center. So we're going to manage our parts, and we're going to add a blank. So if we go add new, and I'm just going to use the project name, Baluster Project Photo, and give this a blank size. Now if we look at the actual blank, okay, this, if I recall correctly, is 1 5/8 inches. We can actually add some parameters on here so you can see correctly. So we'll add some vertical dimensions from here to here. Okay, yep, 1 5/8 inches. And this inner diameter section here that the cylinder is going to be turned to is 1.5 inches. And the overall length of my blank, I need to do a horizontal dimension, okay? The length of my blank from here to here is 34 inches. Okay. Now, I like to have my blanks a little extra long, and then you can trim them to length to accommodate any scenario. That's because a lot of the time you'll have fixtures like a 4-jaw chuck that's going to come and clamp on the outside of this blank, and your X0 may be shifted forward a certain amount. Actually, on my machine, if we look at this, my machine, the X0 is positioned not here. Okay, so if I draw a circle, let's say a 1/4 inch circle that represents a 0 point, my XY0 is not positioned here on my machine. It's actually positioned 1 inch forward. So if we took that and we move this forward 1 inch, okay, this is where XY0 is located on my machine. So because it's 1 inch forward, I'm going to add an extra inch to pretty much this length, okay? Because if I add an extra inch here in the front for my fixturing, then that will accommodate how I'm holding it in the machine, and I can still keep these parameters in play. So I'm going to add 1 inch to my blank size. So instead of 34 inches, I'm going to add 35 inches. Again, because of where my X0 is located on my system. So if we go here to CCAM Pro, we're going to go length is 35 inches long, and the thickness is 1 5/8 inches. Okay, and this is a 4-sided square component, and we're going to save that. So now we've created this blank called Baluster from Photo, and we can close, and you can see that's been added to our turning center list. Now if we click on that blank, we can now add toolpaths to under this blank. So if we go Manage Toolpaths, here's where we're going to add listings of toolpaths, and on the right hand side we get to choose the types of toolpaths that we can produce. Now looking at this design, really the first and only thing that we need to do before doing these contours on either end is to turn all of this round to 1.5 inch diameter cylinder. That's all that has to happen. Okay, so we need to know a couple parameters for that, but let's just lay out the toolpaths in general. So if we're going to turn this round as a cylinder, that will be one toolpath. We're going to have a contour on this end, that will be a second toolpath, and we're going to have a contour on this end, that's a third toolpath. So this entire spindle will take 3 toolpaths to create in Conversational CAM Pro. So if we go here, and we're going to first do the turning round. So that's a turning technique. We're going to turn a round section in the center, so we'll add that to our list. And now we're going to do the 2 profiles, and those are actual importing techniques. So if I go here to import, I have a vector turning, which is what we're planning to do as an import. We're taking the 3-axis flat and we're converting it into a turning because we're taking the vector and turning it into a turning. So we'll take that and add it twice. Now I can actually take this and copy it. And so now we have around, a vector turning, vector turning. We can click on any of these and actually retitle them. So if I want to rename this to, let's say, vector turning 1, or should we say contour 1, because I gave the contour 1 name to the first toolpath, right? Or to the first G-code that we generated in the Maverick software. And I'll just copy this, and now we'll go to this one and go rename and call that contour 2. Okay, just to keep myself a little organized. So we have 3 toolpaths that we've laid out, and we can now close this, and they're going to be added right here under my blank. Now they're highlighted under this kind of grayish color, but that's because they don't have any parameters tied to these toolpaths yet. So if I click on round, it's going to open up the questionnaire process in order to program this correctly for our spindle. So the first thing it's going to ask is what tool do we want to use to turn this center section round, okay, to the cylinder. Well, we're going to go use a very simple cutter. It's called the classic, the surface planing cutter. We use it all the time for turning stock round. And this is going to do beautifully. It's going to take about anywhere from 1/4 inch to 3/8 of an inch per pass, rotating at 16,000 RPM. This is already pre-filled out for feeds and speeds, and so we can just select that tool. And this is going to be, I'm going to say tool number 1. It automatically defaulted tool number 1 here if we want to use it for 1, or I can override it to be any tool number I want if I want to place it somewhere else. Regardless, if you're auto tool change or manual tool change, we still need to organize this by tool numbers. So we're going to use tool number 1 for our surfacing cutter. And is this stock already turned round? Well, no, we just put in a square blank into the turning center, and this is the first process, so this is not turned round. So we need to know where the starting position is going to cut. We need to know the diameter that we want to turn it round to, and we need to know where we're going to stop turning at the ending position. So let's go find those parameters in our drawing. So in our drawing here, we need to add some parameters. We have the diameter that we want to turn to, but we don't have where we want to start turning along our x-axis. So if we add some dimensions here, and again, if this is x0, okay, in the machine, to here where we're gonna, we need to start roughing all that material away, that's the square section where it ends, that is 5 inches, okay, in the x-axis. So we're going to start cutting at 5 inches, and then if we click on 0 again and go down to this end, I'm going to bring that down. We're going to stop turning at 29 inches, okay? So we have 5 inches and 29 inches is the start and stopping point for our turning, but we're going to turn it around to 1.5 inches. So let's go back to CCAM Pro and tie those in. So 5 and 29. So our starting position is going to be 5. Our ending position is going to be 29. And we're going to turn it to the diameter of 1.5 inches in diameter. Now these are all default feeds and speeds, okay, and I recommend using them as you get started with the machine. I am actually going to increase some feeds and speeds just for the cutting purposes of the next video so we can speed some things up for you guys. For example, the roughing pass is going to take 3/8 of an inch at 300 inches a minute. I'm going to pretty much triple that speed, okay, just cut it 3 times faster pretty much. The finish pass is still going to take 1/8 of an inch because I do want all of this middle section to have a nice smooth finish for us, so that we have minimal sanding afterwards. And so we'll keep that defaulted at 1/8 of an inch, which leaves a nice smooth finish. However, I'm going to kick the feed rate up to match the same speed as my roughing. So we're going to kick that up to 1,000 as well. And the finish pass, I'm going to say it can take the same amount in depth as the roughing pass. So we'll just kick that back up to 1/4 of an inch. And again, these are all from preference and experience using the machine. They're not necessary for you to change. This is just me speeding up the process for the actual cutting demonstration. Okay. Last thing I'm going to tweak is as it's plunging into the material while rotating, I'm going to double that speed as well. And this is now finished. The key elements that we needed to put in was the starting position, the ending position, and the diameter, and we had successfully programmed this turning round sequence using an 1.25" surface and cutter. So if we go finish and save, this is now no longer highlighted because it has all the parameters filled out for that process. We simply need to repeat that for contour 1 and contour 2. So let's go to contour 1. And we need to import the G-code, and that's what this file is. Select the G-code file. So if we click on this field, it's going to bring open a search window, and we can go locate where we place these G-codes. So I put them under my project folder here under Techniques, Technique Contour Turned from Photo. And here's our G-code. So I have contour 1 for import G-code, and then there's the second one. So I'm going to use the first one because that's what I'm doing right here, vector turning contour 1. Open, and we're selecting our mode. If this is a delta system, which is what we're assuming that most of you are using at this time, you're going to be having turning as defaulted. If you have a Mach 3 system, then you can use indexing, but the turning is what we're going to be focusing on at this time. So we're going to set our RPM as defaulted to 200. I'm okay with that speed. If I went to a larger diameter, like 4 inches or bigger, I'd probably slow this down. But being only an inch and 5/8 in diameter and smaller for these cuts, 200 RPM is going to work just fine for our rotational speed. The section diameter is what is the diameter that we had previously turned it round to in the last toolpath. So that turning round process that we did just barely, the rounding process, we turned it round to 1.5 inches. And so we're just putting that section diameter so it knows where to start cutting from, so we don't waste any air time above the material. Now we can select our tool. So we talked about how we need to match the tools from Maverick to CCAM Pro, because in this one, we're going to be using a tapered ball cutter, right down here, tapered ball cutter that has an 1/8 inch, okay, an 1/8 inch tip. Okay, you can see the radius of the tip is a 1/16 of an inch, so the diameter of the tip is an 1/8 of an inch, right? So that will match the diameter of the tool that we used in VCarve. As long as they match, this will work out beautifully. So we're going to select this tool. I'm using the 1/4 inch diameter shank one versus the super long one. That's because this isn't going to cut into the material very deep. I think just less than 1/4 of an inch. And this is going to be tool number 2, okay? Because the surface and cutter is tool number 1. One of the last things that we need to do after selecting the cutter, because all of these parameters allow you to adjust different things, but rarely are they used. The only thing you need to really pay attention to is the auto calculate your step over, which is going to take the tip of the cutter, which is 2.5% of the tip, and that's how far it's going to travel down the material every time it rotates. And that will give us a nice smooth finish. And so every time I use this, I say auto calculate yes. It simplifies the process and it gives me a smooth finish every time. Okay. The last thing we need to do is bump up our Z clearance. And so if we take a look here at our drawing, the difference from where it starts to where it cuts, this is way up here around 2+ inches in the swing diameter, and this is around 1.5 inches. I just want to put in a larger number than the difference of that starting point. So 1/4 inch, just round it up to a bigger number, 1 as an example, and that will be enough to lift up out of the way and clear anything that as it's moving, which is perfectly fine. Okay. And here it says a warning saying, oh, hey, your maximum diameter is larger than your section diameter. So here's our section diameter, which is 1.5 inches, but it says your maximum diameter of the cut is going to go up to almost 2 inches. Now, and that makes sense. That's because of that line right there. The cutter's going to actually start at this point and then cut all the way down over here. So we're expecting that to take place with this tool path. But this is just indicating where it's going to start and stop in the X position and the minimum and maximum diameters, which is perfectly fine. Okay, now we can repeat that for contour 2. And so if we click on the field here at the top to import our G-code, go find our G-code here real quick under projects and techniques. There it is. And contour 2 for import, right? And we're using the same parameters, same section diameter, right, 1.5 inches. And then we're going to select the same tool, which it already has it pre-selected here from the last time we chose it. So we can just go select and exit. And this is still tool number 2. Last two things is we're still going to auto calculate our step over, just like the last one. And our Z clearance, again, just round it up just nice and high. Just give it a Z clearance of 1, and that will clear everything just in case. And finish and save. And again, it will give us the same type of indicator, which is fine. All right, we have now successfully toolpathed all 3 of these toolpaths, and we can save these out and send them over to our machine. So if we go over here, we have all of our toolpaths checked, and we're going to generate our G-code. There it goes, it generates the G-code file for us, everything needed to run that, which is beautiful. And now we can save our G-code. And for now, I'm going to put it in the same folder that I had all my other G-code files, projects, techniques. And we'll put this here. So I'm going to call this the baluster from photo master G-code. Okay, so I know it's the final one that I need to use, so I don't confuse any of these other G-codes with what I'm doing, but this is the master G-code that has combined all this into one file for us, and we can save that. And we are now finished, and in part 3, we're going to go show loading, setting up the machine, and then cutting that part to get the finished results of our baluster. It's really nice that we're able to take an entire profile and export it out and then bring it into Conversational CAM Pro so that we can convert it into an actual turning function. We're going to see that actually take place in the cutting in part 3. So if you're interested in learning more about a legacy CNC, feel free to visit our website at legacywoodworking.com. If you'd like to talk to a CNC expert because you have questions, then feel free to call 801-491-0010. You can also leave any questions or comments down below. Now, if you're interested in seeing more demonstrations, either in software or cutting demonstrations producing CNC projects, then I recommend that you click right over there. Don't forget to like, subscribe, and check that notification box so that you can be notified when new videos come out. And as always, thanks for watching. And remember, Legacy solves more woodworking problems than any other CNC manufacturer in the industry.